Okay, guys, welcome to functional Tricity number 3. This is Jezen, and he's going to tell us a few words about Haskell. I think a lot of words about Haskell.
Just a few.
Just a few. This is for you.
It's mostly pictures.
Yeah.
Yeah, so I'm going to be talking about Haskell a bit. I'm guessing everyone here has done some functional programming, or at least is interested in it. I'll be talking about Haskell and also about a web framework called Jezen, which is written in Haskell, and a Linux distribution called Nix OS. Maybe anyone used that? No? Anyone heard of it? A couple of people have heard of it. So yeah, functional programming, like category theory and monads and everyone like that kind of stuff? I don't know anything about it, sorry. Very, and I'm not a maths kind of guy. I failed maths at high school. I was drunk, sorry, Polish, that's fine. But still I can release software in Haskell. And people think of Haskell as this very academic, very mathematical language, and you have to like really know your stuff, and I'm clueless, but still I managed to ship stuff that I have confidence in because the tool is powerful enough. How do I switch slides? This shows my technical competence. Like I said, I don't really know what I'm doing, and I still think that's relevant because a lot of people, when they try and get you to learn Haskell, they say that you should learn it really, really slowly and that you should go through all the material, and there's really long books. You go through like Real World Haskell, or there's the Haskell book by Chris Allen, I think his name is. That's sort of the really long path to get to building a product, but I don't have the time or the patience to sit through all this study to be able to release something and share some project with people. I'd rather like get stuck in quickly without knowing everything at first. And I think Jezen as a framework allows me to do that. I think it's my next slide. Oh no, motivation. So I started, that's the only stock photo I have. I started like a lot of people with imperative programming with crappy languages like PHP, which I thought was cool at the time. Someone's laughing. I know, times change. And then I was tired of releasing broken software all the time. I was tired of maintaining software, like you fix one thing and now you have 2 bugs and it keeps growing. You always have broken software. So then I learned about TDD and all the different kinds of testing that you can do, and I learned about the whole software craftsmanship movement. And sort of really taking pride in your clean code and this kind of thing, and I got a bit religious about it, like a lot of people do. And I'm quite good at TDD. I'm comfortable. I do Ruby every day. It's my daily bread right now. But the problem with that is that puts all the responsibility on the developer, on the human, and aren't really good at being like rigorous and being disciplined. It's not the, in my mind at least, it's not the best choice. I think machines are really good at being rigorous and disciplined. They'll do exactly what you tell them all the time. So yeah, I moved away from enjoying sort of untyped interpreted languages like Ruby and PHP and JavaScript because I want the machine to do the work for me. I want the machine to like verify the fundamental correctness of the system and tell me when I'm wrong, because I'm wrong all the time. We're all wrong all the time. And using a better tool like Haskell helps me with that, I think. Okay, so yeah, this is the framework that I use in Haskell is called Jezen. It's a Hebrew word for foundation. That's not Jezen, that's a guy called Michael. I couldn't find a logo that was like high definition for the talk, so I just use a picture of his face. I think this kind of goes to show that the Haskell community aren't yet very good at selling themselves. Like Ruby was a nice language, but no one had heard of it until DHH sold it to the world. Like, you know, oh, here's how you build a blog in 15 minutes. You should use Ruby on Rails. And now it's like the most popular web framework because it sold really well. You've got to have some marketing, even in development. And Haskell kind of sucks at marketing, so that's why I'm here to try and sell you this dream. So yeah, framework, author. He wrote the framework. Nice guy too. Haskell developers sometimes get this, people think, oh, they're like ivory tower snobs. Like, no, they're nice people. This is a pretty tenuous slide that I have. It's a bunch of performance figures, and the exact figures are not really important or that interesting, I think. But performance always comes up in, if you have like language wars, you're discussing what framework's fastest, what language is fastest. I used to work on a team in Poland using a really crappy homegrown PHP code base. And I suggested once that we start doing things with Ruby instead. Because, well, is that someone's car? I suggested we start doing things in Ruby instead because it's a nice language to work with. And someone said, oh, but Ruby's so slow. It's like, well, it's probably fast enough. But people are sort of really obsessed with performance figures.
You were discussing with the people who are doing it in PHP?
Yeah.
So it's not an argument.
Exactly. So that's why I'm saying this is a bit sort of tenuous. I think it's a bit silly because you can also tune machines specifically to perform better in certain test cases. I think in this chart, these are two different machines, and one makes Haskell look fast, and the other one makes it look not so fast. So you can, sorry? WAI, which is Web Application Interface, I think, is one of the servers for Haskell, and then there's another one, and I don't remember where it is. But it's not really important. It's just the point that I kind of want to make is that if we're going to have a discussion about performance, like, yes, Ruby's tiny bit slower than PHP, and JavaScript is a little bit faster than both. The last figures I saw from memory were something like, actually I can just tell you. So Django, Python, a simple like ping pong request server, like testing throughput of a server, that'll do 2,500 requests a second, whereas the equivalent Node.js JavaScript thing will do just over 11,000. Whereas Haskell is up there at like 81,000. So it's just nice knowing that with Haskell you do get a whole bunch of good performance as well, but it's a difficult case to make, I think. Cool, so I'll talk a bit now about Nix OS, which goes really nicely with Haskell development and also any functional programming development. Nix OS is a Linux distribution. It markets itself as being pure and immutable. Whether or not it actually is pure and immutable is debatable, because it can't really be pure, otherwise it would be useless. But it has this really nice concept of reproducible builds. So you define or you declare the infrastructure of your machine in one central config file, and then you just tell it to build it, and it will build the whole thing. Because usually when you're building a machine, like if you have something like Capistrano or whatever, it's this like imperative stateful approach. Like it'll SSH into a machine, and then it'll copy some files around, and then modify some file, append something here. And if anything goes wrong, which it's likely to, since the network is not reliable ever, then your machine is in a faulty state, and you have to try and root around and find what went wrong. With this, you can't really put your machine in a faulty state ever. And also, it doesn't ever change the state of packages that you've installed on the system. So if a new version's coming in, it'll leave the old one in place and just install things side by side, but completely separate from each other. So if you upgrade some packages or anything like that, and something breaks, you can just roll it back instantly, because it's just like symbolic links in the system to versions of software. And NixOS is not just a Linux distribution, it's also a package manager called Nix, which it uses for, if you're building a NixOS machine, it uses the Nix package manager. So you can use the Nix package manager even on like OS X, or maybe Windows as well, I'm not sure. But you can have any other flavor of Linux and run this stuff on there side by side. And the third part of this sort of ecosystem is a thing called Nix Ops, which is for server provisioning and deployment. That's what I use for deploying my Haskell projects. It's set up to work with either Google App Engine, I think, or Amazon EC2 instances, and that's what I use. So I don't really have to worry about deployment ever. Excuse me. I sort of write how my deployment should look once. I did that months ago. And then I can just check that into my version control system. And anytime I want to deploy something new, it just takes the old state of deployment and sets up EC2 instances for me automatically, sets up the database and sets up everything, which is nice. It's nice I don't have to think about this kind of stuff because I don't really care about deployment. I'm not a sort of DevOps guy. I'm just a programmer. So I don't want to have to think about all these infrastructure questions that I'm not really interested in. It's a very hands-off experience for me. So I suggest you check that out. Even if you're not doing Haskell, then check that out as well.
Is this system or package manager written in Haskell? Is there any intimate?
I think, no, I think the connection there is more philosophical in that if you're really into the Haskell promises of immutability and pureness and stuff like that, then you will be philosophically into this idea as well. I think it's written in a lot of Python and maybe a bit of Perl. I don't know. This slide just has some commands to get going. It's not really that important, I guess. It's better to just read the documentation on this. It's pretty well documented. I've written some articles on it as well with all this stuff in it. And it's quick. Like installing the package manager takes like 30 seconds on my home Wi-Fi, and deploying a machine usually takes 10 minutes, like a full compiled Haskell project. I should have mentioned this as well. NixOps is sort of clever enough to know where it should compile your project. So if you're running OS X and you're deploying to like Ubuntu, for example, it will just copy the whole project to your server and then deploy it there because you can't compile for OS X and then run on Ubuntu because that won't work. I don't suggest you do that though. Even though it's clever enough to do that, I don't think you should do that because it takes a long time to upload everything. And it will take resources away from your production machine if it has to compile your software that it's then going to run. So it's best to, what I do is I run a virtual machine with Vagrant on my Mac, and then deploy from there. Installation process is just like curling a script into your shell, which if there's any security people here we might cringe, but it's just the way it's done, sorry. Yeah, set up some shell stuff, and then you can install packages that are completely isolated with this nix env command with the I flag for install. Also, what I do is I use this Nix shell tool that NixOS gives you, and that's like development environments, or isolated development environments, rather. So I can pretty easily like change what compiler version I'm using or what set of packages I'm using, and they're all isolated all the time. I don't have to like throw out the whole system and start again, or like upgrade things or downgrade things. I get everything isolated on my machine, which is really nice. So this is the process for setting that up. You create a Nix expression that sort of tells NixOS what kind of development environment you want, which compiler to use what packages. Then you go into the shell, and then that third line is building a sort of Nix expression for your application from the Cabal file in Haskell's case anyway, because Haskell you use this thing called Cabal for managing your projects. Cool. And this is what my deployment process looks like. First line, install nixops, really simple. Second line, I create this idea of a deployment. That's probably the sad part about nixops, is that it runs around this sort of state file, or actually it's a SQLite database, but you can't sort of like copy them around ever. So if you're working in a team, you'd probably want to have this state file on some shared machine that you all control. Otherwise, you have like one person for deployment, and that's not such a good idea. And then you just say, nixops deploy your application, and it takes care of everything for you. In my case, I use a makefile to both like modify the last deployment and then deploy it. It's really simple. I don't think about this kind of stuff. And it also takes care of really mundane bits like setting up the right SSH user, so you can just say nixops SSH into some machine, and it takes care of everything for you. Cool, so we'll talk about Yesod, the web framework again. Yesod uses a lot of sort of Haskell features like type safety. It has type-safe routing, so in theory, your routes in your application should never go stale, they should never go wrong. And also what this means is, if you say that some resource is referenced by like a UUID, then if someone tries to access that resource but passes in something that isn't a UUID, then it'll just 404 straight away. Like it'll say, I can't find this because you passed in the wrong thing. It won't look in the database for a matching record, or a record that matches the thing they passed in, because it knows that it's the wrong type of thing. Yeah, I called this talk Haskell on Rails because the web framework is somewhat similar to Ruby on Rails. Are there any Rails developers here? Anyone that uses Ruby on Rails? Anyone that uses Ruby? Not a single happy developer here. Sorry. Okay, so Rails has this concept of database migrations, which you probably, who's worked with database migrations in a different language? Some people, good, okay. At least in the Rails world, you write a migration in a sort of imperative way. So it'll run through all your migrations in chronological order. So every migration file has a timestamp on it. And it'll apply changes to the database in the order that you told it to apply them in. With this, because it's functional programming and it's Haskell and it's not really so imperative, you don't tell it what to do to get to a certain state, because this is migrations. You just tell it how your schema should look, and it knows to figure out how to get your database schema to that state. So here I just have some very simple, so there's some simple DSL for telling Yesod what the database should look like, and I have like a user model, and it has some attributes like the name, which is just some text, and then email, a created at timestamp, and a uniqueness index on the user's email.
Is the syntax, is it case sensitive or is it
Yes.
implementation sensitive? Or both?
Both. But Haskell is both as well. This is not standard Haskell, this is a DSL, but it's pretty simple, so it doesn't take much to, you don't need to know Haskell to read that, I think, which is sort of one of the reasons why I picked Yesod, because you don't have to be a hardcore functional programming nerd to get your hands dirty with it. You can just, you know what that does by looking at it, I think. And here we have a simple handler, otherwise known as a controller in most sort of MVC frameworks. If you have, well, if we look back at the routes file, yeah, we have this like root route, just a /, and we call that home route or resource, and it responds to GET requests. If we didn't have this handler in the application somewhere, then it would the compiler would throw a type error saying that you've defined this route. Your application should respond to GET requests at the root route, but you have no handler. And handlers in Yesod follow a sort of naming convention. So this handler is called get home R for route or resource. So it's when you send GET requests to the home route, it ends up with this handler. Simple routing idea. And then the code here, yes, it's Haskell, but you can probably still read it even if you don't know Haskell. It's this imperative step of like, it tries to get an auth ID of the user. That's why, maybe auth ID. And if you have an auth ID, then it takes you to the home page. And if you don't, it redirects you somewhere else. It's simple. A simpleform.com is like my first Haskell project. And it's just, if you have a static website and you need a contact form, you don't have a backend for your contact form, you just send it to me, and then I email it to you automatically. Yeah. Okay, so this is what the code looks like if you're creating a form in the backend, or this is one way of creating forms in the backend. You define like all the fields that your form needs to have, and that will correspond with one of the models in your database. So those are all kept in sync as well. So you don't have this problem of somebody on your team adds an attribute to a model, but you didn't update the form that goes along with managing that model. The compiler sort of keeps you in check at all points while developing. The code is not so interesting. Again, you can just see that it gives you some things out of the box, like custom URL fields. So it'll check that the person is actually putting in a URL and not just like a number or an email address, or an email field for email addresses. And then you have pure fields that are for values that the user doesn't input.
So an HTML comes out of this?
Yes. Yeah, it generates the HTML for you. So in your template, you just reference like the email proxy form, and it would spit out all the correct HTML.
What are these funny operators in brackets?
These? Those are the, in Haskell, those are the infix operators for fmap and then apply. It's like applicative form syntax. I'm sure it's very, very smart, but I don't know. That's just the way you make things work. Yeah. I think going through all this code wouldn't be so interesting. No, it is. You just got to stare at it for long enough. Make some coffee, stare at this slide, it'll work. And if it doesn't work, then the compiler will tell you. That's, again, the motivation for picking a smarter tool. This corresponds with the previous slide where I defined the form. This is where the form is then processed. And you can, if you squint and skip over a lot of the details, you can kind of see, okay, well, we get like, we require an auth ID, so the user has to be signed in, otherwise they can't post to this form. So you have some authorization stuff there. It does some database stuff, selects a list of email proxy users. And if the form is successful, then do these things, like insert something in the database, set a flash message. If it's not successful, then redirect. So yeah, even if you don't read Haskell, you can kind of discern what's going on. It's not that magic, And that's all I got. Thanks very much. I'm sure you have lots of questions.
So what kind of flashes does it have? A simple form is doing that, or
Yes. No, well, I wrote the talk when I was writing the product as well. So I have this thing called asimpleform.com, and yeah, it's basically at work we use static websites quite a lot because they're free to run and they're very easy to work with. But since I work with like a business, they need a contact form or a bunch of contact forms, and there's no backend to process that. And it doesn't make sense to go into our like web application, like our main product, to add routes for processing form data for the marketing site. It's just, we don't want these things to know about each other, really. So I created this external service. There are others like it that are made better as well. Asimpleform.com is just like me in my spare time, and it runs a few things. So we use it at work, and I also use it for handling my book signups, because I'm writing a book basically on the same topic of getting into Haskell quickly. It's called Haskell but quickly. And all my sort of signups for the book are run through Asimpleform. So it just sends me an email when someone signs up to my book. Yeah, anything else? Or?
Did you use any learning resources for Haskell for diving deep?
Sorry, what?
Did you use any learning resources for Haskell before you dive?
Yeah, so the first time I looked at Haskell, I was going through a book called 7 Languages in 7 Weeks. So I learned sort of Ruby from that, and it goes like Ruby, then IO, and looks at Scala and Prolog, and then Erlang, Clojure, ends up on Haskell. It sort of takes you through the history of languages as well. Like once you learn some Prolog, which is from the 70s and is completely insane, once you learn that, then you see where like all of Erlang's ideas came from, because it was originally implemented in Prolog. And then you see, then you look at Haskell and you see where its ideas come from as well. So I just did a bit with the 7 Languages book, and then a lot of online tutorials, and then just playing around with stuff. There are really good books for it now as well. The Chris Allen book that I mentioned earlier, I think it's just called the Haskell book, or Haskell book. I recommend going through that if you want to like really rigorously study the language, because he's very good at explaining everything. Yeah. Anything else?
Are you converting your happy teammates to Haskell? Or are you staying with Ruby?
One of my guys thinks that everything should still be done in PHP, so a little bit of a hard sell. In a perfect world, yeah. I mean, I don't see any sort of business risk in running some small microservice on Haskell. Like, you just run some JSON backend. Any smart developer that isn't afraid of getting their hands dirty can look at it and figure things out, I think. Maybe one day. Cool.
You don't need any extra servers like Apache or Nginx?
No, Yesod comes with a web server as well. It's called WAI, or it's called Warp. I don't know. I don't sort of dig around with that stuff. But yeah, there is a separate web server for Haskell, and a lot of the other frameworks also run on it, like Scotty is one of them, and I don't know, Servant as well.
They are acceptable in performance. They unlike this, because Python in general has its web server.
Yeah, I mean, that's sort of what I was alluding to earlier with all those numbers, like performance figures. And of all the benchmarks I've seen, and they sort of do this all the time, every year, Haskell's always been super, super fast.
And regarding that benchmark, there was also at the top there was this R language. Did you have any experience with
I once saw so this plain text document describing how it's better than everything else ever, but I didn't ever play with it. It looked a bit too academic for me.
That's really poor marketing.
Yeah, I like pictures and colors, and I couldn't get into it.
Yeah, I think a good marketing way about Haskell is that Facebook is writing too on Haskell.
Yes.
Developed
Yeah.
System, and this tells something about the number of concurrent requests that can be processed in one time.
Yeah. It's funny because PHP also does that. Like people who say you should do everything in PHP will also say, well, Facebook runs PHP. And it's like, they don't really, do they?
C compiler.
Yeah. But my understanding is that there are a lot of functional programming nerds at Facebook, and they write a lot of stuff in both Haskell and OCaml, though I haven't used any OCaml. But it's kind of interesting to know that the static type analysis tool they have for JavaScript called Flow, which is really nice, is written in OCaml. So these sort of functional ideas are permeating into their day-to-day work, and it'll spread through the entire industry, I think. I used to do Scala at a banking software startup as well, and they use functional programming to keep all their data in check because it's safer than doing it with Ruby, for example. Yeah. Any other questions? Nope. Cool. So, thanks very much. I'll wait. Pizza. Oh, I'll be sick. Oh. I've been coming here all my life, and I live here, and I still can't get over the price of alcohol. Last night was painful. Oh, thank you so much.
For you.
Excellent.
And
so I throw it to the fans.
To the fans. Okay, thank you very much. You can eat the pizza now and see in, I don't know, half hour on the next speech. There is a beer and there is a pizza, so you can drink and eat and, you know, sing and dance.
You should have given them beer before my talk. Cool. Oh. Yeah.